My name is Dave. I came from China, and I'm currently working on primarily working on the container-related projects, such as Kubernetes, Docker, and something I want to talk today, BuildKit. Previously, I'm also working on contribute to lots of open source projects such as OpenStack and the Safe and something like that. And today's topic is BuildKit. Yeah, so what's the BuildKit? So BuildKit is just I don't know anyone have ever heard about BuildKit. So it's just a toolkit to build a Docker image. It's another toolkit. So we know that Docker can build Docker image, but is any other tool can also build Docker image? So this is a tool that is the best option for that. That is BuildKit. And there are dozens of new features that's implemented in the BuildKit. So I'm not want to go through each of them today. So I just want to talk about the three most major features. That is mounting platform images and more efficient caching, and also the concurrent build. So this is all those features is a problem that exists in the Docker build. So with BuildKit, this issue has been could be addressed easily. So I want to talk this feature primarily today. Before that, I want to talk a little about the backend currently BuildKit is supported. The first is container D, and another one is run C. So with container D, BuildKit reuse lots of the code that's from the container D, not just implement by itself, just reuse the code. So it's able to provide the features such as a snapshot. So you can also use snapshot to do the use snapshot for storage, and also you can push images like what you did with the Docker. Yeah, and with run C, BuildKit could able to process equation with OCI runtime specification, and it's also able to export your Docker, export your image out into a table, which is also follow the OCI runtime specification. So this is the first feature I'm going to talk in today. That is concurrent build. Why this is the new feature that is implemented? Why BuildKit want to do this? Because Docker cannot currently support concurrent build very well. So let's take a look at this example. This is a very simple Docker file which has 3 stages. So the stage 0 and the stage 1 just want to compile some source code from Go down or C, and stage 2 just want to copy the binary from stage 0 and stage 1 to assemble the final Docker image. So it's very simple. So based on this Docker image, you can see that stage 0 and stage 1 doesn't actually have a dependency with each other, right? So ideally, we can we hope that stage 0 and stage 1 can be executed in parallel, and then after that, stage 2 will be executed, and this is the what we want. But with Docker, all these stages will be executed in sequentially. So this doesn't match with our expectation. Before we take a look at how BuildKit addresses the issue, let's take a look at the LLB. So what's LLB? LLB is an abbreviation of the low-level builder. That is terms that is defined in the BuildKit. Actually, it's just a DAG structured graph. It's encoded in prod buffer, and typically it's compiled from the doc file, and also support other kinds of the files such as the gawk file or mock file. Yeah. LLB defines content addressables dependency graph that can be used to put together very complex build definition. So it's able to provide the feature of the concurrent build and make the cache more efficient and make the BuildKit extensible for the data mounting or the nested invocation. With the same doc file, so BuildKit with the LLB could pass out the doc file into a diagram which looks like this. So we can see from this diagram that stage 0 and stage 1 can be run in parallel. And stage 1 doesn't actually need to wait until stage 0 to be finished. So this is a huge improvement if we finally take a look at the performance. If we want to look further into the LLB, we can dump the LLB into a JSON file. So this is how the JSON file looks like. We can see that stage 2 is actually here. It has a input defined there. So we can see the digest that's associated with this stage has which highlighted there. We can search the digest in the JSON file. We can find this digest is actually associated with another instructions, which is actually compiled as Go non-source code. Because stage 1 doesn't have such an inputs. So when we try to build the Docker image, stage 1 don't know there's any such dependency. So all the stage 0 and stage 1 can be executed in a different Go routine. So actually they are running in parallel. We can see there are a couple of the operations here. So OP just represent a vertex of the LLB DAG, and there's other kinds of the concrete operations such as source OP and EXOP and file OP. So in the stage 2, we are copying some binary, which is actually the file operation. You just want to copy the binary from the stage 0 and stage 1. Next, I want to talk something about the cache. So Docker actually has the feature about the cache. So BuildKit did lots of things to enhance how the cache is implemented. So there are lots of things BuildKit done with lots of things around the cache that has been done with BuildKit. So firstly, let's take a look at this doc file. It's pretty simple. So you just want to export the port number, which is 18, and next is going to install some software, Git for example. So we can see the run instruction here doesn't actually has anything to do with the port that is going to export it. So if we want to, if we build this doc file with Docker and update the port from 18 to something else, the instruction that below that will always be executed, regardless if there is any cache or not on your system. This doesn't make sense at all, because the Git that is going to be installed don't have any dependency on the port that is going to be exported, right? But with BuildKit, this is not a problem anymore. You can see if we build this doc file with BuildKit, these instructions doesn't cost us any time at all. You can just use the cache. How BuildKit do with issue? So you just compute a cache key against the instruction that's going to be the instruction that's going to be executed. So before really execute this instruction, it will search the cache key on your system, and if the cache key could be found, so it will use the snapshot associated with the cache key directly instead of rerun the instruction here. Another feature around the cache is that BuildKit allowed to cache directories for the compilers and also packaging managers. The first example here is cache the compilers. It's actually the go down compilers, and the second example is the packaging managers. Next feature is for BuildKit has done around the cache is that BuildKit is able to import or export your cache to a local file system, and also is able to export your cache into a remote registry or the local registry. So this is a big improvement. Consider the case that you don't. This is a fresh build with nothing cache at all on your system. So you're still able to build your Docker image with the remote cache. So the remote registry. So if there is such a Docker image with some cache that hosted in a remote registry, is still able to build with BuildKit to leverage the cache that hosted in the registry. Next, let's talk about the multi-platform images. So how it supports something like ARM64 or ARM platform to build the multi-platform images. We know that Docker supports multi-platform images based on the manifester. So firstly, you need to create the manifester. Next, you need to do some annotation against the different images for different platforms. And finally, you need to push the Docker image into your maybe a remote registry to assemble the final multi-platform images. But with BuildKit, it's pretty easier. You just need to define some arguments in your Docker file. Here, we can see it's a target OS or target arc, right? Actually, it's still based on the manifest, but BuildKit encapsulates all those things into the source code. So you needn't do this anymore with the CLI. You just need to define some arguments in the Docker file. That's enough, and pass the value from the CLI, which platform you are going to be built. This is some steps for you how to make sure the QEMU emulation is supported on your build platform, so you're able to build the fully architected Docker image, and also the step for you to start the BuildKit and check the platform that has been going to be installed or supported. So we have a demo here. Can you see that? Okay. The first step, this step is just enable the QEMU emulation on different platforms. So we have done this for the ARM64, and next we are going to start the demo. We are using the containerd backend. So we are checking the worker. So make sure the platform is supported. So you can see that both AMD64 and ARM64 is available. Let's open the doc file, and you can see some arguments defined in the doc file. It's going to build the Docker image. And then finally, it will push your Docker image into a remote registry. Here is is hosted in the Docker Hub. And then we're going to check the manifester for this Docker image. The second one is the image that we just built. So we can see both AMD64 and ARM64 is defined in the manifesto. And this is the AMD64 machine. So I'm going to pour the Docker image, and finally we are going to run the Docker image. And it will print the platform information. So it's AMD64. So next we are going to switch to another platform, which is actually ARM64. And it's print ARM64. So this is the demo. How to use BuildKit? So BuildKit is actually a standalone project. You can use it by itself, no necessary to depend on other projects. But it can also be integrated with the Docker as a backend of the Docker, and also Kubernetes as well. So this is how you can use BuildKit with the Docker. The first option, you can opt in by just set environment variables, which is named as the Docker BuildKit. And when you set this environment variables, the Docker will build your Docker image with the BuildKit by default. So it will leverage all the features that BuildKit supported. And there is also another CLI plugin, which is named Docker buildx, which is available as an experimental feature since 1903. So it's kind of next generation build command from Docker, and it has a familiar Docker UI and full capability of the BuildKit. So this is two options. You can use BuildKit with the Docker. And you can also use your BuildKit with the Kubernetes. Actually, there are two use cases how you use the BuildKit with Kubernetes. The first use case is for CI/CD pipelines, and maybe you can deploy a couple of the demo. The demo is a Kubernetes cluster, which is actually the BuildKit demo, and you can. This can spread your workload into different demo. And another use case is which is to improve the developer experience. So maybe you don't have a very powerful developer machine, so you can just start your demo in the Kubernetes cluster and from the heavy workload. These are some steps you needed to integrate BuildKit with Kubernetes. Firstly, you need to start a pod with the rootless BuildKit images, and then you need to also set environment variables, and in order to let BuildKit know where your daemon is, so it can build the Docker image. Finally, let's take a look at the performance comparison between the BuildKit and the legacy Docker builder. It's based on the Dockerfile from the upstream project moby, and it's time for full build from the npm status. We can see that with BuildKit, it's actually two times faster than that of Docker 1803. And another performance comparison is you can actually build your Docker image with BuildKit plus the option of the cache, so which you need to specify --mount after the run instructions. So BuildKit is able to preserving the cache of the compilers and packaging managers, so it will be more faster. And here we can see with BuildKit, it's actually more than 13 times faster than that of Docker 1803. This is very attractive performance result improvement. Okay, so this is all I have today. So, any questions? Okay.
I have one problem with BuildKit. It's not supported in Python bindings.
You not support what?
I have one problem with BuildKit. It looks nice, etc. when you run Docker build on your own. But if you do it by Python bindings with Docker P, you don't have BuildKit at all because it's not supported.
With Docker, which version? Which version?
BuildKit is since Docker 1809, right?
Yeah.
And I do a project where we use Docker in Python. We're using Python bindings.
Yeah, yeah.
And bindings don't support BuildKit yet. So
yeah.
That's
so we can only use BuildKit since at least from the 1803. Yeah. Thank you for your question. So if it's not supported, you can just use BuildKit by yourself. So not necessary to integrate it with Docker. So thank you.